Hey everyone, welcome back to DIY Chris. I'm Chris, and in this episode we are going to fix a Commodore 64 that someone sent me, and I don't remember exactly what the issue was with it, but I do remember vaguely that they did a fair amount of troubleshooting themselves. So I think what was happening was that there was a black screen, so most likely some memory issues, maybe. You can never tell with those, right? Okay, it's a little dirty. I think, if I remember correctly, this guy said that he purchased this, and you know what? Before anything else, let's go ahead and plug it in and see what's up. See what we see. All right, so let's go ahead and turn that on. And an out of memory error. Huh. Okay. Well, that would definitely indicate an issue with the RAM. So, a lot of this is just going by memory. So I remember, I think, that what was requested is that, or one of the things that were requested was to socket all the chips, which, wow, this looks like it's going to be quite a bit of chip socketing if that's the case, because none of them are socketed. Like, there seems to be this, which I'm not sure if that's the customer did that or right. So yeah, we've got a 25407 board, and we are getting out of memory errors. It's like he also said that he tried to, I guess, remove the PLA himself and put a socket in, and said he wasn't having a very, I guess, easy time doing that. Yeah, this doesn't look too horrible. I am wondering about these RAM chips. They're all 4264 RAMs, all 200 nanoseconds. Looks like the replacement that's in here also same kind of deal. Interesting. Plaster. I have not had any experience with the plaster yet. Apparently it has some configuration that you can set. Yeah, it's really in there. Always hate pulling these guys out because the pins are so fragile. interesting. And it's a pretty neat design. I have to look at and see what. Yeah, I'm gonna have to fix this for this guy. This is not so good. All right. So, you know what I want to try? You don't, because I haven't told you yet. But what I'm going to try is I'm going to put in the diagnostic cartridge. And we're going to run the dead test. Where's my cartridge? And see if it blinks at all. Sometimes that's helpful to spot some bad RAM. And it's flashing 5 times. Nope. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So, with that in mind, let's look that up. I should remember these by now, but let's see here. We're looking for dead test manual, and we're going to look for 6 flashes, and that would point to U22. U22 is this one right here, which is next to the sketchy RAM. So we're going to desolder that one, and then we are going to put that into the memory tester to see if the memory tester thinks it's good or bad. So we're going to start with, let's here. So for those of you who've not seen me do this before, I am just basically I'm adding some new solder to the old solder and just kind of reheating the whole thing. This is going to make it much easier for the desoldering gun to pull up all the solder and free the pins, so that we don't have to do a whole lot of work to try and get this chip out after the desoldering. Sometimes the desoldering gun works great, but it can only do so much. So still, the best way to get things done in any case, whenever you do anything, is it's always in your prep work, right? So if you do good prep work, we should have good results. Let's try that again. Alright, that's a much better experience. It still sounds off. All right, so here is the here's the chip, and here's my memory tester. Still haven't gotten around to fixing my other one yet. Okay, so that's pretty good indication that chip is bad, but just to be sure, let's find some other RAM. I got a couple of other ones around here. Okay, yeah. See, that's what a good RAM looks like. It just keeps going back and forth, testing low and high voltages. And here's the one that I just pulled out. And that's bad right away. So what I'm going to do is I'm going to go ahead and put a socket in and hope for the best. So we're going to put this in. And plug in our stuff and have a look. Still out of memory. Okay. Let's have this thing run again. Now it's getting one flash. And one flash, I think, is either this one or this one. U12. That's this guy. All right. Let's take off U12. Alright, so that would be this one. And this one here. Alright, another bad one. Let's go ahead and drop in another socket. Alright. Now, let's drop in another memory. Let's drop in another RAM. Another piece of RAM. All right, let's see what we get. Still out of memory. All right, well, it doesn't seem like we're making any progress here, although we did find 2 bad RAM chips. We're now getting 4 flashes. Okay, now if I'm reading this right, 1 flash, 2 flashes, 3 flashes, 4 flashes. Should be U23. So let's have a look, see if I'm right. Yep, 4 flashes is U23. Okay. So, let's go ahead and take out U23. So, right next to the one we just replaced. Wonderful. Alright, let's see if we can take this other one out. And that's U23. Okay, let's have a look at that one at the tester. And put that in. Bad. Okay. That is now 3 bad RAM chips. Let's see if we'll go for a 4th. I've been down this road. It usually just ends up being almost all of them. So let's put it in the corner. All right. Well, guys, what do we think? We're thinking we're going to make some progress. See something other than an out of memory error. A black screen, perhaps? Oh, ha! You need to put a memory in there. Oh, man. I was so worried for a second. Hey, look at that. No out of memory errors. And I did that troubleshooting with just the dead test cartridge. How cool is that? Now guys, it doesn't always work this way. This was just a very lucky case. Okay, so it's black, and that means we give it about 10 seconds and it'll actually go into its diagnostic test, which is good. So since we're at this point, let's go ahead and run a full-on diagnostics test and see where we're at with the rest of this board. So I'm going to connect, I'm going to change to the jumpers, and I'm going to connect the diagnostic harness along with my dongle, which I've actually fixed. I know there's a couple of videos, and I don't know if I'm going to show this one before I show these other ones, but there are a few videos where I complain about the IEC dongle not working, and that's finally took the time to look at that and figure out that the issue was that the solder connection inside had come loose, so it wasn't fully connected, obviously. All right, so now we're going to run this diagnostic test. And so this will tell us, number one, if all the RAM is good, it's going to test our peripheral chips, the CIA1 and 2. It's going to do some basic checking with the basic kernel and character ROMs, and then it's going to, well, it's also checking the RAM, the color RAM, and it's going to do a rough check on the SID chip. We should also then, when we're done here, check the SID chip separately and see where we're at. Now, this all looks pretty decent so far. Oof, okay. I'm hearing a few inconsistencies with the SID chip, which is not so good. Not so good. It's actually not so good. Not so good. Not so good would be like saying not so good. Or sorry, that would be like saying it's good. So when I said not so good, it's like a double negative, right? So we're basically turning it around. Okay, so the other thing that this guy sent is in this box, and I'm just going to look at this. We have a Backbit Pro cartridge. This is the PLA replacement. That's what this came in, and okay, so he's got his original PLA chip in here. 906.114-01. Look at that. Oh, very cool. Okay. I've never used the Backbit cartridge. I don't know what it is. But I definitely am going to open it up and look at it. Breathe new life into your vintage computer systems. Backbit Pro, which is what this is. There's also a Chip Tester Pro and a Genesister. Modern hardware for vintage computers. Evie Solomon. Don't know Evie. Okay, so here is the Cluster configuration. Okay, so number one, we can add CAS/RAM delay. Okay, so that's required. It's not always required, but if you're having issues with this particular chip, then adding a delay on the CAS/RAM will a lot of times fix those issues. Kernel override is interesting. I don't know what that is. Cast run jumper increases cast delay from 25 to 30 nanoseconds. It's a very, very small delay, but it is significant. The kernel override requires Backbit cartridge to be inserted. And this is printed on a 3D printer, obviously. There's an SD card in here. A 32 gig SD card. So this is interesting. Looks like there's a headphone jack in here. Backbit Pro adapter for Commodore 64. I'm very interested in what this is going to do. Private Eyes quiets the data bus to facilitate in-circuit testing with the Backbit chip tester. Okay, we don't have the Backbit chip tester, but the Private Eyes. Okay, that's number 3. So all of these are off, which is fine, and that should work for most situations based on the information on this card. Okay, so the Backbit Pro cartridge. Navigate with joystick or up or arrow keys. Sorry. Type name to search. Return to run. Press stop break to go to basic. Press F1 escape to view utilities. Then see bottom of screen for other hotkeys. Utilities and options. Create directory. Look from disk. Set clock. Startup colors. Properties. Rename file, saves. Okay, so important. Do not operate without case. Power off machine before plugging in or removing cartridge. Attach adapter to cartridge before inserting into machine. All basic stuff. To upgrade firmware. Place BB Pro upgrade in the root. Okay, so on the SD card where you would put the firmware, I guess would update the firmware on the Backbit. About saves and versions. Original is newer, never altered, modified file stored in hidden saves folder and can be exported. BBT stores versions internally. Use contact cleaner, cartridge slot, cartridge. It's troubleshooting, optional accessories, additional Backbit Pro adapters, back button, wired remote. Gen Assister, joystick adapter, chip tester, pro, and replacement parts. So I don't know. I'm confused still as to what this could possibly be. Looks like he also has a broken standoff. Which is cool because we have case fixing components. So this is an interesting print. Okay, so we've got a big screw here. Yeah, I'm not going to take this apart because it's not mine. So, and I'd like to see the inside because I'm always curious. But yeah, I'm not going to take it apart. I do want to plug it in and see what it does. Although, let's see, we're in 7 tests, so we've been running really good. RAM is running cool, which it should be. And I haven't really heard anything else bad from the SID chip. Kernel usually runs a little warm. So is basic. Character is usually okay. Not really feeling anything else happening here. This should be pretty toasty. Yeah, seems pretty hot. 12 volt usually stays pretty cool. Not a whole lot happening on that. All right. So, yep. I'm going to go ahead and turn this off, disconnect the harness, and when we're all done with fixing this thing up how the customer wants, then we are going to go ahead and run this thing for a good, I don't know, I usually do 150 cycles, which usually ends up being about 2 hours of runtime, and that'll give us a good idea that things are actually working the way they should. If the Commodore can stay running for a good 2 hours without dying, then usually, you know, things are okay. Backbit. There's a whole bunch of games on here. That's pretty sweet. Okay, so it's like one of those cartridges that you could just put, you know, games on. That's cool. Let's see here. Let me test this keyboard without shorting anything out. Okay, so we can use the arrow keys. Feels like this keyboard might need some cleaning. I'm just gonna go to a random one here. AC/DC pinball. That sounds fun. F1 is, I think. Alright, let's go back and look at the instructions once more. Press return to run. Yeah, okay. So I guess we just need to really press down on this. That's a good indicator that the keyboard needs to be cleaned. So, okay. Usually, it's either space or else AC/DC pinball or F1. One of these. Like I said, the keyboard, sorry I'm banging on this really hard, but nothing. Okay. So the keyboard most likely definitely needs to be cleaned. So yeah, I'm gonna come check back in on this in a little bit. Gotta go do a couple of things, but you know, to you guys it'll be like no time has passed, so it's all good. All right, so it's been a day for me. It's been instantaneous for you. And after some communication back and forth with the customer, they decided that what they wanted was they want me to basically take all of the chips. So we're talking about RAM, right? All of these RAM chips. And we're talking about the CIAs, basic kernel, character, CPU, and basically desoldering them and putting in sockets. And then what we're going to do is we're also going to remove the VIC shielding. So we get rid of that. And then we're also going to recap the board. So lots of things happening here. So what we'll start with is, since we've already started socketing this RAM, let's go ahead and remove the rest of these RAM chips. So just so that I don't lose myself, I'm going to make sure that I mark which ones we're going to remove. So we're taking this one. We're taking this one. And we're taking those three here. 1, 2, 3. And yeah, as you can see, we've got quite a few chips to desolder. So I'm gonna go ahead and heat up the soldering iron, and what else I'm gonna do is I'm going to clean off this because it's just gonna get in the way and be annoying. All right, cool. Oh, and we're also going to remove this socket. He actually tried to solder himself and definitely got too hot because it started to melt. And yeah. So, soldering iron should be ready. So I'm going to just go ahead and in one fell swoop, I'm going to go ahead and put solder on all of these to get them ready for desoldering. And then we're going to grab the desoldering gun and do the desoldering. Cool. Okay. I thought I heated this up already, but it's not. Just take a minute and clean. That's what was in there. There. I'm going to replace the I'm going to replace this. This is gross. Should not look this bad. That's probably not part of my problem. Get a filter. Uni filter. Okay. This thing back together. Back in here. Yeah, because it's got to suck through here. I mean, this is... Yeah, I actually think that sounds a lot better. Okay. So, let's do this. Be able to come right out. Sweet. Okay. So first things first, let's clean a little bit around here. I'm just gonna take some isopropyl alcohol and clean around these parts here. Get rid of some of that solder, flux, solder, flux. The other ones didn't look so bad, but it's never a bad idea to clean, especially since this will be really the only time that you've got this kind of space to clean stuff. Usually the sockets are all in the way. Yeah, so even though it didn't look dirty, it was, obviously. So before we can put sockets in here, there are 1, 2, 3 that I want to clean up a little bit. first. Oh. That one. And that one. All right, let's do one more final sweep here. Right. Those are nice and clean and ready for sockets. Yep. Okay. So, see, we need 1, 2, 3, 4, 5 sockets. And then after we get these sockets in, we're going to put the RAM back in just to make sure everything still works. It helps whenever you're doing some big project like this to always make sure you go back and check after you do any kind of major change that everything still works as expected. You don't want to like go in and be like, all right, well, let's change, let's put in sockets, let's recap the board, let's do all these modifications, and then do all your modifications, and then come back and turn it on, and it doesn't work. Like, it just won't turn on, black screen, blue screen, whatever. And what would you troubleshoot? Where would you even begin? You've made so many changes. What would be the best way to fix your problem? You wouldn't know, because, like I said, the amount of changes you made were way too much. And so you'd have to start back from scratch. Or in some cases, you may not even be able to fix it. You may have ripped off a trace somewhere while removing a component, and while you might eventually find it, it's going to be rough. So, yeah, this is what I do. I always check. Also, I think the other thing that this guy purchased is my SRAM module. So we're going to be replacing the RAM that's in here with one of those. Okay, those look good. So I'm going to go ahead and solder the corners of these. Alright, so this obviously will need to get cleaned. But for now, for testing, let's go ahead and put the RAM back in. And I'm looking at the feet of these RAM modules, or the leads, not the feet. Just to make sure that they don't have any big globs of solder on them, because these are just regular, like, dual leaf sockets, and if there's anything on the leads that is wider than the lead itself, then they're going to easily widen those sockets. So I'm just going through and with the iron making sure that everything is nice and smooth. Trying not to burn myself in the process. That one looks good. This one. Sounds good. Seems okay. And this is that one that was in the corner over here. This one's pretty bad. So let's see if we can clean it up a little. You know what? It's not worth it. Let me grab another RAM, which I have literally just sitting right here. All right, cool. So I did realize that while I was doing this, that one of the capacitors kind of just fell off. So I'm going to replace this one, which is going to be a 10 UF capacitor. Those are pretty easy to desolder. So yeah, it already fell out. So as far as 10 UF capacitors, what I usually do is I use these ones here. They're a little smaller in profile, so that's just fine. I actually think they look a little better because they don't take up as much space. Okay. Let's do this. Let's put these leads. Right. So now we should be at a place where we could do a test. So let me put this PLA back in, just because I want to make sure that everything is still working. Yep, we're going to need power. Let's do it. Okay, everything looks good. All right. So that means we didn't mess up any of this. Very, very happy with that. Although we still have quite a ways to go. Let's make an easy modification. Let's remove this RF shielding from... Looks like he already tried to do that. There's already quite a bit of solder missing here. So there's a couple of things. One, this thing here. And for doing this kind of work, I usually have a different tool because these this might be, I think these are too big for, yep, too big for the nozzle. So what I have for that is I use this solder sucker tool. Not my favorite thing in the world because it's not easy to use, and it's just something it's like one of those skills you just pick up with time, but it sucks. I hate it. See what I mean? Totally did that wrong. Yeah. Make it easier to remove. See? Same deal here. Get some solder on the side. And then we're just going to pull. And this one just already wants to come out. Not really much holding it. Sweet. Okay. And that would be that. Alright, so let's clean that up. Yeah. So, just going to put some solder here. And same thing here. Here. And here. Cool. So might as well clean that up. Same on that side. Looks like we have some excessive solder over here. Alright, cool. Clean that up a little too. Now, as much as what we just did most likely didn't break anything, we still need to check and make sure that everything is still working as expected. Just to be on the safe side. Because now, if it doesn't work, then I'll know that I need to concentrate in this area. If I check it again after I remove these chips up here, then I'll need to widen my area to this area, right? And then if I do it after I replace all of these, I might as well check the whole board. So that's why I say always, always, always check. If you're doing this kind of stuff, every single opportunity, check. Good. All right, so the VIC chip is already socketed, so I'm not even going to worry about that. We're going to go ahead and let's go ahead and just get these big ones out of the way. The CIA chips, these two, and then after that we'll do another check, make sure everything works. These are two 40-pin. So the first thing, like always, we're going to go ahead and, okay, just gonna resolder. Wow, that was amazing. I love it when that happens. Chip literally just fell out. That's awesome. All right, let's clean the top of this. Okay, looks like we have some cleanup to do. Over here. And down here. That's why that one didn't fall right out. But the other one, that was beautiful. I loved everything about that. Clean the bottom here. Whatever solder or whatever flux was in whatever solder that they used here to initially solder these in, is super disgusting. So I'm trying to clean off as much of that as I can, because these do get harder to clean once you put the sockets back in. All right. Let's do it. 2 40-pin sockets. And then I eventually need a third one, so I'll just keep this one on the side. Oh, this one's missing a pin. You know, when I order these and they get shipped to me, obviously, the pins are always so bent. Like, it's always takes a good, 30 minutes or so to just sort through them all and make sure that all the pins are good. And, sometimes you end up missing one. That one's a pin. Number 2. Cool. And this time, since we replaced the CIAs, and the C64 literally would turn on even if the CIAs were missing, I think it would be a good idea to run a diagnostic test. Okay, all good here. Let's put this in. Put this in. And we're going to connect this really quick. And we're just going to let it do like 2 cycles, just to make sure we're still good. Because when I'm done replacing these sockets, I don't want to have to do any more troubleshooting. I already did that. I already fixed the problems. I want to cause more problems. That cannot be right. Yeah. This is what I'm talking about with this diagnostic cartridge. We now don't show any errors for U1 and U2, or as we did before, we had some errors. So weird, huh? Huh. Okay, now it's I guess a good as time as any to run out of space on the SD card. I wasn't sure how much space I had left on there, but apparently the SD card is out. Anyways, our test is good, so I'm going to turn this off. I'm going to have to come back because I need to deal with this SD card. Okay, so SD card has been dealt with, so anything going forward will be captured on the video. Well, the output of the C64. So I'm going to go ahead, and since everything is working, and we tested with the diagnostic harness to make sure everything is working, I'm going to continue down a wonderful path of socketing these ICs. And I'm going to go ahead and do the CPU next. And then after the CPU, we're going to do a test, make sure everything still functions, and then we are going to desolder these three, and we're going to do another test, and then we're going to desolder all of the capacitors, and put those back in, and then we're going to do another test, and oh yeah, and we're also going to desolder the PLA, which I think I'm going to do in conjunction with the CPU. So since he just did desoldering on the PLA, here actually, you know what, let's desolder that first and get that out of the way, and see if we run into any issues. Okay, so this should just pop right out. Good. Doesn't look like we've lost any traces, although we should clean this up a little bit. First with some isopropyl, and then we'll come back and see if we need to clean up any solder. But I think this looks pretty good. Came off really good. So we'll do the same thing on the back side. All right, cool. So go ahead and put a 28-pin socket in there. Okay, now we can put in the PLA, and I'm gonna press it down all the way. All right, now let's give it another shot, make sure that we did that right. And it looks like we're still good to go. All right, onward. Oh man, so yeah, if you look at the socket here, you can tell there's definitely way too much solder on these pins. All right, let's do this. Okay. Okay. Put that in. Very good. Okay. Let's go ahead and plug in our power, video cable, and we are good to go. All right. Now, getting down to it, we have 3 ROM chips to remove. So let's get these done. First, I'm going to start with putting solder as usual. All right, that was fun. So let's see if we did that right. Come on. you waiting for? Okay. Very good. Character wrong. Kernel wrong. And last but not least, the basic wrong. Right. Cool. Let's go ahead and clean that up. Let's clean up the backside a little, although the backside looks pretty decently clean. But it's not. It never is. There's always something. All right, now we need 3 24-pin sockets. Very good. This one's bad. The first thing I do is always I'm looking at the pins, because I've done this once, maybe twice, putting in a socket, starting to solder it in, and then I notice some pin is missing here. Yeah. So that happens. So now, never again. I always check the pins. Okay, just hope that this looks pretty good. So we'll do the corners real quick. Okay. This one here. Let's make sure these are all flat. one actually looks pretty good. Just going to come through and make sure all the pins are flat. That's the kernel. And here's the character, without which we would be seeing no text or any characters. Text is just a character. Sweet. All right. We have basic kernel character, the CPU, the CIA chips, the PLA, the SID, the RAM, the VIC. So let's go ahead and make sure it still powers up. And it looks like it does. Very good. Very good. Okay. Now, next. What is next? Next is to replace these guys. So let's go ahead and desolder these capacitors. So we've got this one here. That side of the board is completely decapped. So let's go ahead and put some new ones in. And then we're going to do this other half of the board. When you're doing these, be sure that you're putting these in the right direction. They're polarized, so they should only go in one way, and the board is marked. There's a plus sign, like right here, next to where the positive side of this electrolytic capacitor goes. The electrolytic capacitor, on the other hand, also has a marking, which is usually a different color, indicated by also a rectangle, which could represent a minus, right, for negative. The other way that you can tell is the positive lead is usually the longer one. And on the motherboard, if you look, you'll see that the positive side will be a square versus the negative side will be a round hole for where the leads go through, right? So, like I said, you'll want to make sure you put these in correctly. Otherwise, you'll have issues. Right, there's one more up here. Okay. Let's go ahead and solder these in. We've got 1, 2, 3, 4, 5, 6. And then we're soldering 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5. Always count them to make sure that you're putting the right amount back in. It's easy to skip over one. So counting the one that we had already replaced earlier to fix the broken one, we have so far replaced 7 altogether. And not counting the bigger ones, I believe the total for the 10 UF capacitor, the count I believe is 13 altogether. So we can verify that if we count the rest of them, right? So we did 7, so it would be 8, 9, 10, 11, 12, 13. Okay, so 13 then, because there's nothing in C107, that's right. Okay, so let's grab these 3 on the bottom. So let's get 1, 2, 3, 4, 5, and 6. Alright, so this should satisfy the 10 UF capacitors. These 2 right here. Okay. Let's go ahead and solder these in. Great. These all look great. So there's another one here. This one is 100 UF. So let's get that one. Great. Have to clean that, I'm sure. Yep. And it's because it's the ground plane. It just needs a little more heat. Weird. It don't have a string on it. I wonder if it had some sort of tag or something. Okay. So got 100 UF right here. Drop that in. Great. Now, all we've got left are the 3 big guys. All right, so that is 1,000 UF. This one is 2,200, and that one's 470. All right, so got our 2,200 UF. I think we've done everything that was requested of us, meaning me. You guys watched, so I guess you helped supervise, right? Okay, look at that. All in working order. Okay. Oh yeah, no, there is one more thing. SRAM module. Let's see here. First, let's get these RAM chips out of here. Unplug so we don't do anything bad. Alright, so here we have an SRAM module for a 25407 board. We built this just a little bit ago. And I'm going to have to move some of these capacitors. These are not usually as big of a deal. Alright. Oh, what the fuck? Oh, was I not? I wasn't lined up. Okay. Yeah, and boom. Oh, we're not all the way in yet. Hang on. There we go. Cool. Move these back. Let's upright some of these. I like how they're all leaning. Okay, let's turn it on. And there we go. Everything looks good. Yay. So we've got leftover components here. Junk. All right. So what's next for this? Next is actually doing some work to this case. All right, this one's good. This one's good, but this one needs to be replaced. And so I'm going to go ahead and put one of these on here. And since we still have some of this stuff, usually super glue is okay for this, but since we already have it out, might as well. Okay, so that just sits there, and it's already at the right height. There's a little lip on it that makes it stop exactly where it's supposed to. So that takes care of that. Let's go ahead and see if we can put some sleeves over these posts just to keep the keyboard strong. Not the keyboard, but the top of the case. Just kind of will help keep these posts from completely falling apart. All right. These don't actually look too bad, but no reason not to do these. Interesting. They do seem somewhat widened. Okay. You have to do that and be very careful when you do it. All right. So now I'm just going to put this keyboard back. So the customer originally asked me to take the keyboard apart and clean it, but that's an extremely laborious task, and you know, I guess the amount of money I quoted him for that was not worth it. So and I get that. I would probably have not gone with that service either, because you know, it's actually something, it's not too difficult to do yourself. The most difficult part of it is desoldering this, and that's not difficult. Literally, to clean the keyboard, all you need to do is basically reverse what I'm doing right now. You know, take the screws out, take all of these screws out, get it out of the case, and then take out all of these tiny little screws. Before you take out those tiny little screws, though, desolder this. And the way you do that, just get yourself a small pair of pliers and heat up this side and pull on that. Heat up this side, pull on that. And then take off all these little small screws. And then what you're left with is just this piece, which will come right off. And that's the PCB for the keyboard. And with that, you'll see there's a whole bunch of contacts. So those contacts will need to be cleaned, most likely, if your keyboard is having issues performing, like when you have to press down too hard on the keys, or one of the keys just doesn't like come up at all. It's possible that your contacts have worn down, in which case you'd have to, there's like this stuff that they sell on Amazon that you can get that'll actually like not tin, but resurface your contacts for your keyboard keys, which will actually make it so that you can, you know, use your keys again. Damn. Why was that so hard? Alright, this will be my control. And this is still drying. Okay. So what I'm going to do is, since this is still drying and we have some time to kill, I'm going to go ahead and lay the board into here. And I'm going to go ahead and put in the screws on the top. So here. Here. And here. And then once this is completely dry, what I'll do is I'll come back and we're going to just very slightly come in with a drill and drill out the hole so that when we thread the screws in, it alleviates some of the stress that we would put on that. Not that I think that it's going to fall apart, but I think it'll just be better that way. Yeah? I mean, less stress is good for everybody, even boards. Okay. All right. So I just need to remember to do that because right now what I'm going to do is I'm going to just put the rest of this back together so that we can do diagnostics and oh yeah, this will be fine. Cool. All right, so we're not going to screw it in, but I am going to go ahead and plug in all of the things. To do a diagnostic. Where is my... There it is. Always losing this damn thing. Should put it on the string. There's that, and the harness. And the controller. Great. Then the power. And the diagnostic cartridge. And let's see what happens. And this will be the actual burn-in test. So I'm going to let this run for like 2 cycles, and then I'm going to pause it, the video that is, the recording, and you guys will not see 2 hours worth of diagnostic testing. So the reason that we're getting keyboard bad right now is because the keyboard is not open. Right. It's open now because the shift lock key is open, right? Because before the shift lock key was down, so it obviously interpreted that. All right, so we got 2 good cycles. I'm gonna go ahead and pause the video here. When we come back, this will the bottom of the case will be dry, and we'll be able to put the last 3 screws in. Then we'll turn it around, put the screws into the top of the case to connect these pieces together, and then we'll be done. So that's literally all there is left in the video. So yeah, I'll be back with that in a bit. All right, so just in case you guys didn't believe me, we're still running cycles. It's been running for 2 hours and 28 minutes, and we are just in 151 cycles. I don't know if I've said that already. But yeah, so we're good. Every single time the test is run successfully. It's a little warm in there, but nothing crazy. Yeah. You know, definitely the hottest chip in here. It's probably the basic. Honestly. Actually, it's like a tie between the VIC and, yeah, definitely the VIC, then the basic, then the PLA, the kernel. Oh, sorry, not the PLA, the SID. These capacitors are pretty warm. The 5 volt, that's the hottest thing in here. Alright, cool. So I'm gonna go ahead and turn this off. And yeah, so let's see here. I'm very suspicious of this epoxy that I was using, because the epoxy that I had mixed on that piece of cardboard is still not dry yet. So I'm going to go ahead and move to plan B, which is using this other kind of glue that I have. So I'm going to go ahead and finish that up, and then we're going to put this thing back together, and we'll call it done. This isn't all the way dry. Yeah, it's rubbery. it's definitely got a hold of it. So I'm gonna say let's go ahead and drill into it. You're not gonna need to. Okay, and let that dry. All right, we'll let that dry. All right, so here we are. The final stages. We have everything together. All of this looks really good. I'm really happy with the way this turned out. Yep. So let's just turn it on one more time. Looks good to me. I also want to try to put in Guiana Sisters, of course, because that's what I do. Oh, we're going to need the keyboard for that. Which I forgot. And that sounds just about right to me. Just connect it to the LED. That's also working. Go ahead and pop this on. Perfect. Press space. Okay, so yeah, the keyboard needs definite cleaning. Okay, yeah, that's it. Actually sounds pretty good. That's a happy sound for me. ahead and put the screws in. Okay, so these screws don't seem to want to tighten. I have some special screws that we can replace these with. Let's turn this off for a second, because now I feel like I need to do something. All right. Now, oh, here they are. Okay, so these I marked these specifically. These are made, specifically designed for brittle plastic. So as you can see, they are the same length, but they have these special threads that are supposed to cut into the plastic in such a way that it's not going to damage it. So let's see. Okay, that one actually tightens in all the way, which is good. Nice. Oh. Good, good, good. All right. Okay. So what I do want to try is, I want to try the keyboard. I already know that the keyboard's going to need some cleaning, but I want to see just how bad it is. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, U R S T E V W X Y Z. Okay, so most of those actually turned out okay. 1, 2. Oof. Yeah, so some of these will need some cleaning. 3, 4, 5, 6, 7. 7 actually works okay. 8, 9, 0, plus, minus. So it's mostly 1. Actually, they seem to be working okay now. This bottom row had some issues. I think it's just a matter of using it. I think maybe it's just dusty in there. Spacebar is going to need some love. I think though, every time I do it, yeah, and it gets better with time. So yeah, looks like all of the keys work. So there's no issue with the keyboard. It's just that it needs to be cleaned. So again, that's not something that I'm going to do. So yeah, that's the Commodore. It's working and ready to go. We did look at this Backbit cartridge as well, which has some games on it. So that's pretty neat. And we did a diagnostic test, ran 150 cycles through that. We replaced, well, to begin with, when the system wasn't working, we found out that there were 3 RAM chips that were bad. We replaced those. Customer wanted to replace all the RAM with an SRAM, so we did that. We then also socketed all of the important chips. So all of that is done. And we are good to go. Oh, we also removed this thing here. So that would be the end of it. We're done. We are done. I hope you guys enjoyed this video and learned something from it. And if you did, give me a thumbs up. Don't forget to comment, subscribe, click the bell for notifications, and thanks for watching, and I'll see you guys in the next episode.